Welcome to all of you. In this session, we are going to understand the timer programming examples in assembly language programming. Let us go through the question. Write a program to generate delay of 20 microseconds and send logic 1 on port 2.0. Assume oscillatory frequency is equal to 12 megahertz. Try to understand the question first. So we need to create a delay of 20 microsecond. After that, we need to send a logic 1 signal on port 2.0. So we need not keep the program in an infinite loop. Once we do this, that is sufficient. And if you are going to keep that in an infinite loop, still it is a correct program. Then what is the oscillator frequency? It is 12 megahertz. Now we need to calculate the count value so that it can generate 20 microseconds of delay. It is given by count into 12 divided by 12 into 10 to the power of 6. So this is the oscillatory frequency equals 20 into 10 to the power of minus 6. So this is nothing but the 20 microsecond delay. So we know how much is the delay. For to create this delay, how much count it has to do, that we need to calculate. So take this 12 divided by 12 into 10 to the power of 6 to the right hand side so that we can calculate the count value, and this is what the representation. By resolving this, we are going to get 20 in decimal. Converting that into hexadecimal, it is 14 in hexadecimal. So that means if it counts 14, then it is going to create 20 microseconds of delay, right? So any timer 0 or timer 1, so both of them are going to be up counter. So after rollover from its highest value to the 0, then only the flag will be set in the TCON register. Therefore we cannot start from 0. How much count we want? So from the maximum, so decrease it by 14. So that's from where the starting point of the counter will be. So to do that, so we are going to have FFH highest value in the hexadecimal. So we are considering timer 0 in mode 1. Mode 1 in the sense 16-bit counter. Therefore, this is the highest value. So FFH minus 14H, that's what we have calculated, plus 1. So where it is going to give us FFECH. So this is the value that is required to be loaded to the timer. So since we are considering here the timer 0, so TL0 consists of EC, the lower 8 bits, TH0 consists of FFH, that is upper 8 bits. So total 16 bit. Now let us get into the programming part. So first we need to understand, so we are using timer 0 in mode 1. So that means we need to understand how to configure this TMOD register as well as TCON register first before getting into the program. So in the question, they have not told which timer we need to make use of. So either timer 0 or timer 1. Any of these we can select for the further operation. So in this case, in this example, I am selecting timer 0. So this is TMOD register representation. So since I am not making use of timer 1, all the bits related to the timer 1 are set equal to 0. So I am using only the timer 0. So what configuration I need to make in the timer 0, that is what observable. So we are making use of timer mode 1. Therefore 0 1 is what? Mode 1 representation. Those two bits are set. Then next thing is, this is counter bar timer. So if it is set equal to 0, it is going to act like a timer. Therefore we are going to make it equal to 0. So gate, we must be set it to 0 for a regular count operation, for regular delay creation operation. So this is what the configuration of TMOD register. By the value, if we observe, this will be in hexadecimal. 0 1 H is what we are going to get. In the TCON register, so we have to concentrate only the bits which are related to the timer 0. Therefore, all the bits that are related to timer 1 are set equal to 0. right? So in the timer 0, observable and required facts are TR0 and TF0 with respect to the timer delay creation. So TR0, if it is set equal to 1, then the timer starts counting. Therefore, we must set this equal to 1. So TF is the timer overflow flag. When there is a rollover from the highest value to the 0, then this is going to set automatically. So initially we have to keep this equal to 0. So other bits related to the timer 0 must be kept equal to 0. So this was the bit configuration of TCON register. By observation, we can say that TCON register in hexadecimal value, it will be equal to 10H. Right? Now let us get into the programming part. So first set the tmod register as we have discussed. So its value is 01H. So move tmod comma hash 01H. Now this is going to configure timer 0 in mode 1. Then we need to load TL and TH values with respect to timer 0. So move TL0 comma 0 ECH and then move TH0 comma hash 0 FFH. Then after we need to start the timer. Therefore we need to make this TR0 bit equal to 1. So this is for the configuration. Move tcon comma 10H. Try to remember. So just before performing the count operation, you have to use this instruction. If you use this tcon configuration at the beginning itself, so without loading the initial value what we require, if we enable this tcon register, then there is no use of it. So first configure tmod, then TL and TH, and then only enable this counting operation, that is the configuration of the tcon register. Right? So this is going to start the timer counting operation. Now wait until this fifth bit of the tcon register is set. So that means timer overflow flag of the timer 0, whenever it is going to set, it indicates there is a rollover. So how much is the count value we have taken? So it has to count for 20 microseconds. That's what the calculation we have done. So once there is an overflow, then TF0 is going to set. Once it is set, it indicates that 20 microseconds of delay has been completed. Then we have to set the port 2.0. So set bit port 2.0. So it is going to set port 2.0 to logic 1, and then after make the tcon register is equal to 00. All bits are 0 in the sense, so this counting operation will be inhibited. Right? So TF overflow, that will also be set equal to 0. TR0, that will also be set equal to 0. That means the counting operation has been inhibited. So this is not going to run for infinite loop. So this is going to run only once. Let us get into the one more question. Write a program to generate square wave of 1 kilohertz on TXD pin. Assume oscillatory frequency is 12 megahertz. See, in this case, time delay is not given directly. Instead, it is given in an indirect manner. So we need to generate a square waveform of 1 kilohertz. And we need to send that on TXD pin of 8051. So we'll have a look at the TXD pin, which is the TXD pin later. And oscillatory frequency is 12 megahertz. Right? Now, square wave of 1 kilohertz in the sense, one complete square wave is going to be of the span 1 millisecond. So this is what the representation. So here, since it's a square wave, on time is equal to off time we have taken. So including both of them, it is what 1 millisecond, and individually it will be 0.5 millisecond, 0.5 millisecond, right? So that means we are trying to identify the delay count value required to create a delay of 0.5 millisecond. Since it is same for on time and off time, we are not creating 1 millisecond of delay. It's a square wave, on time separate part, off time separate part. So we need to identify the count value required to generate 0.5 milliseconds of delay in this case, right? So formula it remains the same. Count into 12 divided by 12 into 10 to the power of 6 is equal to the delay value, that is 0.5 millisecond. Now calculating the count value, we are going to get 500 in decimal, and this is what is its equivalent hexadecimal. So since timer is a up counting operation, so we need to identify from where we need to start the count so that it can satisfy this many number of count values. So that is FFFF minus 0, 1, F4H plus 1, that is equal to FE0CH. So this is the starting point. So again here also remember we are using timer 0 in mode 1. Mode 1 in the sense, so complete 16-bit we are going to make use in the timer, right? So that's why the value FFFF is being taken over here. So if it is mode 0, then this value is going to be different. So since we are using timer 0, so TL0 now consists of the value like this and TH0 like this. So these are the values that we are going to use in the programming. Now let us first understand the configuration of TMOD register and the TCON register. Right? Remember timer 0 in mode 1. Right? So that means timer 1 has nothing to do with this one. Set all the bits equal to 0, that is related to timer 1. Timer 0 in mode 1 in the sense, so this configuration 0 1 with respect to M1 M0 is going to configure it in mode 1, and then as a timer we need to work, so this bit is 0, then get is equal to 0. So tmod configured. Tcon register, so we are using timer 0, therefore so we are concerned with TR0 in order to start the counting operation, right? So TF0 overflow, automatically it will be set whenever there is a rollover from the highest value. Therefore the configuration will be like this. So this is tmod is 0 1, tcon is 1 0, right? So now let us start with the programming part. So the TXD pin they are asking. So TXD pin is nothing but port 3.1. That's for the TXD pin. So first we are going to make that as 0. Right? On time is 0.5 millisecond, off time is 0.5 millisecond. So initially we are going to set it equal to 0. Then after configuring the tmod register, move tmod comma #01H. Then after we are loading the value of TL0 as well as TH0 respectively. Then after we are configuring the tcon register, move tcon comma 10H. Now this is going to enable the counting operation. Now wait until the timer 0 overflow flag in the tcon register is going to set. That means whenever I roll over from the highest value, then it is going to set this particular flag. So once it is set, it indicates that 0.5 milliseconds of time has been completed. That means we have cleared the port 3.1. So it is in the off time. Therefore, we are going to complement the port 3.1 so that when it was 0, now it has been converted to 1. Then configure tcon register tcon to all 00 so that we can stop the timer and clear this overflow flag, and then make a jump back to the repetition. So this is a square wave, so we have to keep that in the infinite loop. Reconfigure TL0, TH0 and tcon register and keep repeating the process again and again. Right? So this is all about timer 0 in mode 1. Let us consider same concept if we make the configuration using timer 1 mode 1, how values are going to change. So now as you can observe, which are all in the blue color, so those values are just updated, right? So now first thing is tmod register, right? We are using timer 1 means only these 4 bits will come into picture. So timer 0 has nothing to do Therefore, keep all the bits of the timer 0 equal to 0. That is done. In the timer 1, configure that in mode 1. So that means it is 0, 1. M1, M0, 0, 1. Mode 1 configuration done. In the timer mode, set it equal to 0. It is done. Then get it is equal to 0. When it comes to the TCON register, you must make the observation only with respect to the timer 1 related bits. Any bits that is related to timer 0 will be always set equal to 0 here also. So in order to start the counting operation, TR1 is the required over here. So that will be set equal to 1. And TF1 is what observable later. So initially it must be set equal to 0. All other bits are equal to 0. Right? So now we can identify the configuration. So in the T mod register it is 10H, whereas in TCON register it is 40H is what we are going to have. Right? And also the values, count value what we have calculated, that must be loaded to the timer 1 register. Right? So that's what we can observe here. Now that clear port 3.1 save, then move tmod comma hash 10H. So timer 1 in mode 1, then move TL1. Make observation over here. So it is TL1 here, TH1 here, corresponding values, what to count values we have calculated, those values are present over here. So then move TCON comma 40H. So TCON register has now updated. Then wait for which bit? TF1 is the bit what we have to wait for now. Right? So that's the timer 1 overflow flag. So that's what we are waiting for. Once it has been completed the counting operation once, then it is going to create 0.5 millisecond of delay. Then complement the port 3.1. It was 0. Now it will become 1. Then stop the timer and stop and again repeat the process again and again. So since it's a complement operation, so every time the on time off time will keep toggling and it will be creating a delay of 0.5 millisecond. Right? So either you can use timer 1 or timer 0 in this case also, because in the question they have not specified which timer, which mode you have to make use of. Right? Now this will be one more question. So assume hexdial is equal to 22 megahertz. Write a program to generate a pulse train of 2 seconds on port P2.4. Use timer 1 in mode 1. I am leaving this for you to make a solution. Just to note that, so oscillatory frequency here it is 22 megahertz and overall one pulse duration is 2 milliseconds. So you can just split it into 1 millisecond and 1 millisecond, as good as a square wave. You can just try to make it out. Total time is 2 seconds. So you need to create 2 seconds of delay for one complete pulse duration. On time off time, you're just going to split it as a square wave realization. On time is 1 second, off time is 1 second. Use timer 1 in mode 1. Why? It is asked in the question directly. Right? So try to make out the solution for this one. Right? Thanks for joining.